Plan for today, trying to replicate this. This is the tool post holder for my lathe. This is a center boring tool installed. It has a half curve. When you rotate this, you're able to move the tool height up and down. And apart from that, what you do is change out between left hand tool, right hand turning tool, center boring tool, and a parting tool. That's the four I have, but I have a separate parting holder. This holder, right, I can buy another one. To be honest, that's not that difficult. Thing is, $32 US for this, and that is without any shipping internal in the US, then shipping from there to here, then taxes, value added tax, online purchase tax. This is the same size aluminum. This is aluminum, by the way, 1.25 inch aluminum, exactly the same size. This locally cost me about $6 US. As you can see, it's a lot bigger. I bought it for several different things. I'm going to try to do the attachment to my compound sign also, because the compound sign is just crap. It is wrongly designed. Anyway, so yeah, it's a lot bigger, right, as you can tell. So I can get actually 3 corners on this, but that's not what I intend to do with it. But yes, probably get 2.5 for this, right? So I intend to build this out of this. 6 US. I mean, big difference between 50 and 6. This curve that allows me to turn this up and down isn't really necessary. At the end of the day, if you cut this groove in at the correct position, right, it's just a matter of shimming. Once it's shimmed, the purpose of what I'm trying to do is essentially make this so I can just switch out these tools fairly fast without having to realign, recenter. You have to turn that and recenter everything. It's a pain in behind because this moves and everything else as soon as you take it out, so you have to do over the whole process. So if I can make one tool that can do a holder, that can do a tool on this side, a tool also on that side, right, I can have my 2 other tools, a turning tool here, the center boring, and left hand on the other piece that I'm making. Don't need to do anything except switch out. So apart from the stock material, which is what we got here right now, and I have to cut this, I don't have a forger chuck, so that's a fun. I'm gonna have to do this manually and basically clean it up. But again, this isn't really critical. This is just bolting down on the surface below. And fortunately, this is an end stock. This is end stock from the manufacturer, so this is gonna be relatively square to this, better than I can get anyway. Although on a lathe with a forger chuck, I can get this probably a little bit cleaner than the manufacturer, because he's just gonna do this. If you look at the lines, that is actually just a probably carbide. So, but notwithstanding, it should be fairly 90. I just have to deburr this a little. There are a few nicks on this. Let me see if I can find them. Yeah, like there. I'm gonna have to live with those. If they're too deep, I'm gonna clean it up after I finish. But you know, those, you know, if it's too deep, it doesn't make sense, you know, going down a couple of millimeters or two just to take off the edge of a nick. Right. So the plan is, but just the length, clean up that face, but make that face the top, which doesn't matter. Doesn't really need to be perfectly 90 and flush. But yes. So make that the top, make the manufacturer cut edge the bottom. Mill a groove, not as big as this. I don't see the point in having a groove this big. I don't have any tools that big, so this could come down quite a bit. About this height, slightly below maybe for a shim, or just about the correct height. Maybe slightly below. It's easier to shim. It's feasible to shim down. You can't shim up. So that solves that. These two can't get a hex locally. What I can get are these. But that said, right, I need 4 of these. I have more. What I will do is just tighten this down once. I don't need to do anything again, so they don't really need to be the same size, because once I do this and I tighten it, it's gonna work. I need a center hole. There is a bolt going straight down here. It's a little bit in right now because it's kind of soft, self-threaded itself into the aluminum, and that goes through on the other side to a T-slot, and that's what holds on. Of course, I can't find that locally either, so the plan for that, let's try one of these This is what goes into wood. You pound this into a piece of wood and you can screw onto it, and it gives you a good anchor point. So this looks at about the right height. If you look at it, it's just about the right height. I may have to, and that's when it's all the way in. So with it coming out a little bit, it may work. If not, what I'm going to have to do is going to sink this hole slightly to allow the head to go down a little, and that should work. I've got myself a washer. This has a washer. It's a little bit bigger, but yeah, not a big deal. Worst case scenario is that I'll have to go to the sink and I may not be able to get the whole washer in. I just may have to machine the washer's head a little bit. That's fine. Again, this piece here, it's a lot thinner than this one, but again, this isn't tightened very hard. So it's a matter of taking this and turning it into a square like this. That shouldn't be too difficult to do. So that's the plan. This replaces that, those bolts, that, this, cut it, clean it, drill miller slot on this side, miller slot on the opposite side, and drill 2 holes here, 2 holes there, a hole in the center, cut this up, clean this up, make it work. So let's get on with it. You can see, lots of fun. We're almost finished. It's just hanging by edge, so I just have to chop that off. Lots of fun cutting this with a hacksaw. While it's aluminum, 1.25" is really fun. Well, yeah, it works off easily. Hopefully it's relatively square. I don't know for sure. But then again, this will be the top surface, so it's not that important. But I'll probably run a mill because I'll have to mill down anyway to get that depth. So I'll probably run a mill on top of it and just clean it up anyhow. Managed to smoothen the surface fairly nicely. I think I've gotten it a little bit square, more square than the manufacturer had. As you can see, there's a couple little nicks, and that is from there. I would assume it's a high-speed steel saw, but it could be carbide insert, circular saw. As you can see, the circular marks, it's a circular saw. Notwithstanding, that will not affect the end ability to grab onto the surface, and it may take another 10 or 15 minutes just to get those out. I may end up just screwing it one side or the other, so it really doesn't matter. I think I'm going to leave that instead of trying to be a perfectionist, get that out and possibly cause myself more trouble. Now we can clearly see there is in fact a taper, slight taper, but there is a taper, and I will have to mill back this top surface. So I will use that as the flat. Hopefully it is flat enough, but largely with that there and this on the bottom, I should be able to mill this relatively easily once I set up the milling machine. So yeah, let's proceed. Let me find out where I need to drill those holes. This is where we are at now. As you can see from the line there, that hole didn't come straight through in the center, and I expected that. My drill press is not 100% aligned. This is a cheap drill press. This is what you get. Over that distance, we went from center here to probably 0.5 millimeter off, faint out, and we have countersunk that hole, and that is for, let me find it right, this. So that goes in here, slips in properly, and the bolt will slip in correct size to go in here. Let me see if I can find that bolt. Right, so this is our bolt. No real wobble in it. That's pretty good. That fits down, that goes down right there. And when we countersink, it will all work out fine. So yeah, quite happy where we are right now. Now we have to do the fun stuff of drilling right on the edges here. And this is the part where let's discuss how we thread holes. Theoretically, those should be thread. Theoretically, this is a steel bolt and it will thread itself into aluminum. I have done this before, and we could cut the aluminum, and well, we could cut the bolt and try to make a tap out of it, and that works, and it will cut. Then we'll have to use the correct size for tapping. If not, what you do is you put a 16th less drill bit, and then you just screw this in. It's going to be difficult. Takes a bit of oil. What it does, it really kind of forms the metal, so it cuts, the ridges cut and push the metal into the grooves, so you get a sort of deformation. So even though it's the wrong size, it's larger than you leave tap in, it works for self-threading and forming itself. I've done it before, it worked. Hopefully I don't screw up this after this much work, because it's a lot of effort there, but yeah, let's go for it. A quick attempt at making a tap. Basically, I taper the edge on the drill press, actually, not really up to point of the lathe. I'm trying to do that, and then just take the Dremel and cut 2 grooves, one on either side. Hopefully, I don't have a bolt for this, not for this. If I had a nut, it would have been great to run it up and make sure I clean up the threads. Now we've done the first hole. I think it's successful. I have to look a little bit clearer. I'm not seeing that well, but the light here, I doubt you guys have seen any better than me. But it seemed to have thread. I've been able to run up another bolt into it. It's a little machine, so you can rearrange it. It's rearranged right now in a milling format, milling pies, 3/8 end cutter, end mill, attachment for that, and we're set up. Theoretically, the surface tire ground that was originally cut by the manufacturer is relatively level, because that's what I'm using, and based upon that, resting on this to make the level surface to cut across. So we're gonna have to mill in several passes, obviously. Nothing big, nothing fancy, so it's going to take a few cuts. Obviously, it's going to end up with burrs going in this hole, so I'll have to clean back up these a little bit after. But after I mill this way, what I have to do is flip it the next way and do the end cuts like this across. I'm using 3/8, these are 1/4 inch, so I'll end up with basically 1/8 extra. So I'll do probably half on top, half below, or maybe a little less below and a bit more on top. Let's see when that stage reaches. That has to flip that way after. Then finish, I now have the center go down, plunge a little bit and go down with that hole so I can get a nice depth. But yeah, that's it up. Again, I've run several different ways. There's limitations in space, limitations in what depth of cut I can do. Small machine, I already nicked on one side and caused it to flip up because I plunged and I hooked on the side. I need to go off completely or plunge down in the path. Anyway, let me recess this a little and let's get to flipping it over. Hopefully I can get some deeper depth of cuts out here. I have to cut this way. Obviously if I cut this way, there's a lot less holding force, so it can move up and down. This way it's against the jaws, so it's a lot stronger. So we'll arrange this whole thing and see if I can get the 2 ends milled out properly. The whole finish is not perfectly centered, as you can see, but again I did this manually. You don't have a hole finding tool, so yeah, edge finding tool. So yeah, but it doesn't really matter that much. This has to fit in here and it is actually almost exactly that size, so there's only one solution. I need to turn this head down slightly so it fits in first and goes down. But yeah, we got 3 millimeters down, so we're fine. I need to polish this up a little. This is just the milling marks, so it looks a little bit more presentable. That's relatively easy. Let's cut the 2 grooves first. It's partially true. We probably have about 3 millimeters depth of cut here. I'm going to 7 one side, and you can see the holes are starting to show up. The threaded holes that will go through, so we are fine enough in. I don't know if the threading is fine enough, but we'll determine that when we finish, and then just run up the screws again and get that threading all right, and then polish up everything. So a couple more millimeters on the side, and then the whole next side to do. This is the first side finish. Quite pleased with that. If we put a bar in a stock, we can see it's a little bit lower. It's not quite flush, and that's what I wanted. And we'll get a good grab in. So perfect. Now flip it over and do the next side. The second one, and as you realize, let me see if I can find it. Right, barely seeing this hole. I'm seeing this hole properly, but barely. I got lazy. I didn't drill these things fine enough. I was hoping I didn't have to mill back anymore. I think I can make this work by pushing down a little further. I cannot drill because I tapped it already. I would mess up the threads. So hopefully I can just push the screw in fine enough and just push this material out. It looks like I can. For finished item without polishing, I'll polish that just now. Slight little mark from tapping. Oh, damn. Aluminum particles from tapping. The holes are now fully tapped out. If you one that was a little less, didn't go in fully. This one is a little close. You could see the mark where it pressed the aluminum out. You could clearly see that on the indentation at the end. That was a little close to the end, so it pushed out. It's already half forming, half tapping. So yeah, we're pretty much finished. It's now a matter of just polishing the surface and calling it a day. Errors. This is a recentred. I could have done a little bit better, but not that big a big deal. This next one that was a little too close. Small problem there. What other errors we have? Oh, there's an edge somewhere here that nicked. Yes, This is it here. It's nicked. So yeah, can't see properly from the phone. Let me see if I can put it down and try it back. The phone light. This edge here is slightly nicked, and that was initially when I was making this second cut. I plunged close to it, and the edge of the flute on the end middle hooked and digged in. So there's a small nick there, a littleish nick here, but you can't see that because that got in the process of leveling the surface. So yeah, that's pretty much what we have here. Hopefully this shows up well without the light. So yeah, final polish and then just a quick look at it. Probably spray painted black just to be consistent with the rest of parts that I have. So yeah, I tried the photocopy toner yesterday and that didn't work out as nicely as I would have liked, so I can't use it on this. That was the whole point of that. I can't use it on this. I'll have to spray paint it. No chances that the paint will come off aluminum. Paint normally doesn't hold that well on aluminum, but we'll see what. We'll try it anyway. This is the finished item before painting. It's looking pretty decent actually. Not bad at all. Let me look at this angle. The first set of paint didn't dry at all, and that went really badly. So what I had to do is take some acetone, take it out and put in some epoxy paint. It's not bad. Comparing these two now, if you look, we have the tab. This is a little thinner. This is what I got compared to that. It's in almost the same distance here. If you look on the bottom, it still has a little bit of space, so that is not jamming and not going to hit in the T-slot. The screw has fit in perfectly. A little bit of grind, slight grind on the head, but it's fitting perfectly. We have a double tool post. Let's compare them side by side, and it pretty much is a little bit lower than this, and I want it a little lower because it's a little bit high, so I could shim it slightly. May have to shim it a couple of times. I would say this is a resounding success. Looks very good. Looks very, very, very comparable. I mean, you can't really tell anything off with this. I mean, the most you can say is yes, this is not exactly the correct. You know, these three are one size. This is a different size from this one, so I'll have to use a different Allen key. But once I tighten these down, I set this to the correct position and I set that to the correct centers for machining. I'm not going to change it.